So I have the required pleasure of informing you folks about a star of my choosing from a predetermined list. Now I looked this list up and down and thought to myself, now I know none of these stars really, which kind of disappointed me because back in the day at early elementary and up into about middle school, I was kind of a whiz and a little bit of a buff with the stars. Not like complete expert, but I did have quite a leg up on all the other kids who said they wanted to be an astronaut when they grow up.
Thinking back on it, I don't think anybody went with their when I grow up plans, so I don't really think it matters in the long run.
But back on track, I chose this star because it's an Ursa Major and I like bears. So if you clicked on this video, there's one of two reasons why you're here. One, you actually want to know about this star, or two, you're my professor and you're viewing and grading my final project.
Hi, Professor McCallum.
So with the very sarcastic introduction out of the way, let's get into some star facts. Star in this case being singular because I'm only required to talk about the one. I will now be using notes off my laptop because I can't remember numbers. So Alkaid is about 103.9 light years away from the Earth, while our Sun is 0.00001581 light years away from the Earth. To put that in a bit of perspective, if the Earth is, say, right here, and our Sun is about an inch away, Alkaid would be up in the Namaji State Forest, about 103 miles north by northeast. I wouldn't even be able to get from here to there without needing to stop at a Perkins. So Alkaid is located in the constellation of Ursa Major. It is the third brightest star in its game of connect the dots, which usually makes it easy to spot. Well, to find it, you can find the constellation the Big Dipper and look for the first star in the handle. It is kind of leading the other ones, or if you're looking at the Greek myth, which is why I like it, because it's a bear. It is the actually head of the bear. It's most always above us in our galactic disk, so you just need to.
Alkaid has two other names, one being Eta Ursae Majoris, which kind of feels to me like if someone had a very long and complicated name, like, let's see, Kenneth Reginald Leicester Esquire III, and was like, please call me Keith. And the other name is Benetsnach, which I didn't look a pronunciation guide for and will be confident in however wrong I said it. But it is referring to the daughters or the other stars in the Ursa Major constellation that Alkaid is actually leading.
If you ever come across somebody who's into astronomy and they're trying to sound smart and act like they're better than you by using the word magnitude, take them down a peg and ask them why they didn't use the word brightness, because that's literally what it means. I'm not joking. Brightness. That's it. And if they try to back out and pull the apparent and absolute magnitude, just know that the apparent magnitude is how bright a star would appear in the night sky. So basically what it looks like to the naked eye. And the absolute magnitude is how bright a star would appear from a distance of 10 parsecs. And if you want to take them down a peg as well, if you're like, oh, 10 parsecs, you can know that is okay, never mind. You probably won't be able to get this one right off the bat because I don't even know how to I don't know how to say that number. That is it's like at least 6 zeros out of my knowledge of number names.
So, 1,000, million, billion, trillion, quadrillion.
It's in the quadrillions. So Alkaid's apparent magnitude, or how it appears in the night sky to our naked eyes, is a number of 1.86, and its brightness from a distance of 10 parsecs, or its absolute magnitude, is negative 0.6. So both are actually measured on the electromagnetic spectrum, but it mainly focuses on the wavelengths of visible light, which, if I have actually edited this correctly, should be somewhere from around here to here. Somewhere. I'm recording this before I do the After Effects, so we'll see where I land.
So now I get to talk a bit about the cultural/historical impact and kind of importance of Alkaid. So this is the least scientific and data numberies part. So if you're a nerd and want to get back to the data and charts, go ahead and skip to this timestamp. But regardless, I will be going through each bit quickly because this is a long and hardy process of recording and editing, and I want to get this done tonight. So we're going quick. I'm covering my favorite bit of history first because I'm biased and I like bears. So, in the Greeks' myth of Ursa Major and Minor, it's the source of my favorite constellation once again because, bear. But Zeus comes down from Olympus. He's a beautiful woman named Callisto in traditional Zeus fashion. He has an affair with her, and she has a child named Arcas. So in order to protect her and her son from his jealous wife Hera, I wonder why, he's in hot water with Hera.
Goddess of marriage.
Don't do that, Zeus. Or anyone for that matter. So in order to protect Callisto and Arcas from his wife Hera, Zeus turns them into bears, thinking they're good to go. But Hera finds this out and is like, oh, you don't get off this easy. Here, have a hunter. Go get them bears. Zeus, though, luckily for these people that Zeus finds out, so he grabs the bears by their stubby short tails and absolutely just yeets them into the sky, elongating their tails. So if you see illustrations of Ursa Major and Minor, that is why their tails are so long. It's because Zeus just was thrown at the speed of sound or something. Have to get escape velocity. In Arabic cultures, the star and the Big Dipper is actually representing of a funeral process, with Alkaid, or the one that, the name I'm going to put right here, that I horribly butchered earlier, and the stars in the handle actually representing the mourners, and then the bull representing the coffin or the frame on which a coffin is carried. What, you didn't know that one?
That one I didn't know.
Yeah, I know. That one was actually really funny to me too. I know. Aren't you studying Arabic? Or at least the language, right?
Yes.
Well, there you go. There's a fun little tidbit of information for you. There you go. You can say you learned something today.
I can.
I hope you can too. So the Hindus associated the star with Marichi. I am once again not confident in my pronunciation and will not be checking. One of the 7 rishis, again, I am so sorry if I butchered that. Each star in the constellation of Ursa Major is actually associated with one of these 7 sages, which honestly now makes me wonder if that was the basis for Legend of Zelda 7 sages. So in medieval times, Alkaid was one of the 15 Behenian, I'm gonna go with Behenian, fixed stars, and were thought to have magic properties. So the stars all had plants and then gemstones associated with them, and that would kind of represent the star. And I guess some other properties. So Alkaid had Sukari as a plant. Here's a lovely little visual. Thank you, editing me. And its gemstone is magnet. I wish I could make that up. When I think gemstone, I think shiny emerald or the stupid giant ruby that Abu literally threw his life away for in Aladdin. But no, it's magnet. It doesn't shine. Magnet. Also, the chart of these 15 stars are actually featured on the Portal of Gravity Falls, which is, I will say, another big part of Alkaid's cultural impact, because, without that star, we wouldn't have the Big Dipper, and without the Big Dipper, we wouldn't have, Dipper Pines. That's his entire thing. He has the freaking birthmark in the shape of the constellation. And I'm gonna put a visual right here. See, there it is. I'm so good at editing. I am so tired. This project has been draining me for the past week and a half. I had to write this while in a rehearsal process. Come see these shining lives. Shut up. I just want to be done with this project. We've got another probably 30 minutes of recording to go. And probably another 2 hours of editing. Spectra, using the power of rainbows to show you a star's temperature composition since the 1800s. So special prisms and then chemical-coated papers are used to capture specific wavelengths of photons, whose patterns can then be, identified in the different slots to determine what the star is made of, and then out of that can kind of be a good estimate on how hot the star actually is. Think of it like an elemental barcode of sorts. I would love to just spit the facts about Alkaid, but I'm also required to compare and contrast this part of the project with the sun of our own planet. So here's a lovely visual of Alkaid, and here's a lovely visual of the sun. I'm going to try to keep myself center frame so that editing me has a lovely time just putting whatever I'm talking about on either side of me, saying sun here, Alkaid here, and let's get into it. I also made some funky little comparisons just so we can have a little bit more kind of, perspective on our lovely little, way too far away and our big ball of gas. So the spectra of our sun looks something like this. Here I'll lean this way so I can kind of expand it a little bit over here. So this is the sun spectrum. So our sun is actually made about 3/4 hydrogen, and the other quarter is helium, and with a tiny sliver of a bunch of other elements mixed in there. It burns about 5,778 degrees Kelvin, or if you don't remember how to scale things in Kelvin, because I know I don't, Fahrenheit, the degrees that we normally use, our sun is about 9,941 degrees, or about 4 times hotter than your average conventional oven. Or for you Pokemon fans out there, our sun is about half as hot as a Magcargo's internal body temperature. So Alkaid, in contrast, has a spectra that looks like this. A little different, but you still kind of get the picture of it, so understanding that. So Alkaid is about 6 times bigger than our sun, and although I couldn't get exact percentages on elements, it actually has a similar makeup of elements, with hydrogen being fused into helium, but Alkaid has a bit more of an iron buildup. Alkaid burns about 11,000. So Alkaid burns about 11,375 degrees Kelvin, or 20,015.33 degrees Fahrenheit, about 30 times hotter than a conventional oven, or equivalent to the combined heat of 2/3 of a Magcargo's internal body temperature. There's no reason why this Pokemon would exist. It would literally destroy any planet it was sitting on. 18,000 degrees Fahrenheit. Half of this thing's internal body temperature is the temperature at which nuclear fission is achieved. So now I get to refer to a lovely little piece of diagrammery known as an HR diagram. So on this main graph, you can see how it kind of has this curve. And the thing about this curve is that that's where the majority of stars lie. That's actually on this curve, towards the top of it, towards the blue stars. That's where Alkaid is classified. That is a B3V star. So it's a blue star on the main sequence. And our sun is actually a G2V star. So it has a yellowish white color. So it lies right about there, down here on the main sequence. So generally speaking, the stars on the main sequence are genuinely younger than the stars that are in any of the other groupings. So in terms of the lifetime of these stars, so Alkaid formed about 10 billion years ago, so at least from our perspective of what we can determine from that, it's expected to continue to burn through its fuel relatively quickly over the next 100 million years, and then after that it'll become a giant star, and then eventually what's known as a white dwarf. Our sun, in contrast, formed about 4.6 billion years ago, just a healthy dose of perspective about the number 1 billion. A lot of people don't quite understand the scale of a billion, so allow me to put this into a fun little analogy. 1 million minutes ago, we were just going into lockdown for COVID for the first time. 1 billion minutes ago, chess hadn't been invented yet. It was the year 120 AD. So the next step in our sun's lifetime, it will eventually turn into a red giant in the next 4 to 5 billion years, so you have plenty of time to check off any items that are still left on your bucket list. And eventually it also will turn into a white dwarf. So our sun and Alkaid have similar endings to their lifetime, but it takes kind of a different amount of time for them to get there. Like how a nursing student and a business major have different times to get their degrees, but both eventually get sucked into pyramid schemes. Welcome to my bedroom, a sentence I have never said to any woman. So suppose there's a planet orbiting Alkaid at just the right orbit, and just the right capacities for life. What could we do to contact this planet? Well, considering how far away the star is, we'd probably do one of two things. So I'm going to step off to the side and list our possibilities right here. Actually, you know what? I'm going to do it on this side. I'm doing a lot of left screen facing visuals. So let's go for the right side of the screen this time. Or at least from my perspective. It could be flipped for you. I'm not quite sure. Whatever it is, it'll be the opposite of whatever I've been doing. Okay, so one, we can kind of just make a space probe and hopefully do the right amount of math to shoot it off in generally the right area, and hope after millions, if not billions of years after it travels the distance, we'd have to wait the same amount of distance for anything to come back. The second thing that we could do is start, I guess, like throwing out radio waves or other wavelength communication forms towards that generic area. But that would also take about 103.9 years for it to get there, and then another 103.9 for anything to come back. But given the distance, and then red and blue shift, and then the insanely rare possibility that the planet would understand English or any language on this planet, our message would probably sound something like this.
Not great.
All right. Now on to the last part of this presentation and the last part of my project. The last bit on it, I actually did enjoy doing this part because I had to think about this. I actually needed to personify this star, so I will actually be assigning a celebrity to Alkaid to kind of represent it, and kind of all of its characteristics. So I really had to do some thinking. So they need to be someone who's a bit older, because it's an old star, could be associated with the color blue, because it is a blue star. It's very well known. It is a very well known star on culture. A lot of different people like know what this is, and will later be known as a white dwarf. So right now, in my mind, I've narrowed it down to 2 people. But to make the final decision between those 2, let's think about the personality of this star. So Alkaid, it's burning through his fuel quickly. So Alkaid is impulsive. It's incredibly hot, so Alkaid would have to be attractive, and Alkaid has a lot of cultural impact. So say it with me. The celebrity that would be the personification of Alkaid would be none other than the lovely Danny DeVito. That's it. I'm done. That's the presentation. Now you can go outside, look up at the sky, and say, "Oh boy, there's Alkaid," and I will partly be responsible for that. Thank you. I'm very tired. I'm gonna go pass out now. Bye.